Hello everyone, myself Avinash Kothuru, research scholar, pursuing PhD under the supervision of Professor Sanket Goel, Head EEE Department, Pilani, Hyderabad campus. I would like to thank IEEE Census 2020 for giving me this opportunity to present the paper on the topic Electronic Nasal Pod, a 3D printed device to filter and to electrochemically detect the pollutants. Before I could start, I would like to tell where I come from. I come from Pilani, Hyderabad campus, one of the 4 campuses of BITS universities, established in 2008. Origin and motivation behind this comes from the present pandemic situation COVID-19, which is contagious from person to person, and also the seasonal allergies, particles in air, pollen, dust mite debris, and so on, which causes the allergies, and also the smog, which is a kind of intense air pollution. Survey on Air Quality Index. According to the survey in 2019, World AQI ranking, Delhi from India ranks the first with 529 AQI, which is very hazardous, and average death rate of 292 people a year. Keeping all the considerations and the aspects which has drawn the attention to make the electronic nasal pods. Nasal air filters and the current existing problems and the plan for it. So existing problems are with the filters cannot be monitored, discomfort for the users, and the critical needs are it should be in low cost, robust, simple structure for monitoring. The electronic nasal pods integrated with electronics, IoT for continuous monitoring, filters and HEPA filters, and the highlights are inexpensive process to monitor the pollutants, easy to plug and to handle for the quantification. So the work done. After the rigorous study on the nasal air filters, the designing of electronic nasal pod has been started with ENP cover, inner filter layer, nasal outer layer, and the prototype of the device shows with integrated electrodes. So after the successful complete of the design, the electronic nasal pod was 3D printed using the SLM machine. So the 3D printed nasal outer layer to the left, in the middle ENP cover, and to the right 3D printed inner filter layers, and the HEPA filters and the Wattman filter paper arranged in the inner filter layers, and the total assembly of the ENP, that is electronic nasal pod. So the 3 electrodes for the electrochemical detection. On the paper, 3 electrodes were formed using the CO2 laser, and the laser induced operation using the CO2 laser to the corner. And this is type 2 3 electrode system and integrated 3 electrodes to the electronic nasal pod. So for the detection of oxygen, initially phosphate buffer solution was taken and performed cyclic voltammetry study, and then purged nitrogen for 10 minutes and performed the cyclic voltammetry study again. So when nitrogen was purged, there was no reduction peak. In the plain PBS, a clear reduction peak was observed. Based on the PBS results, oxygen was purged for time interval of 5, 10 and 15 minutes and performed cyclic voltammetry study using the 2 kinds of filters, that is HEPA filter and Wattman filter paper, which shows the linear increase in the reduction peaks. Figure A shows the results for the Wattman filter paper. Figure B shows HEPA filter paper results, and figure C shows the calibration and linear fit curve. Conclusions are it's inexpensive, a low-cost 3D printed wearable device has been printed. Filtrations, that is filter papers of 3 micrometer filter papers were used, that is Wattman filter paper, and HEPA filters were used. Using CO2 laser ablation, 3 electrodes were formed for the detection of oxygen using the cyclic voltammetry, and the results, a fully 3D printed electronic nozzle pods have been shown with impressive results for the detection of oxygen. So the ongoing and the future work. Further modification of the design according to the electronics integrated architecture of 3 electrodes, overall prototype development, portable potentiostat, integrating it with the microcontroller and IoT. And the figure A shows the nasal air filters, and figure B shows mounted microcontroller, and figure C shows the inhaling, and figure D shows the data transmissions. I would like to thank my professor and supervisor, Professor Sanket Goel, and Indian Space Research Organization, Respond Programming. Facilities available in our lab: micro and nano fabrications, thermal evaporation, photolithography, 3D printing, soft lithography, and CO2 laser engraving, and paper-based devices like solid ink wax printer, cutter and plotter. Also for testing and characterizations, digital viscometer, micropumps, conductivity and pH meters, and electrochemical workstation, and common facilities like scanning electron microscope, XRD, etc. And for the simulations, MATLAB and COMSOL. I would like to thank for giving the opportunity. Thank you.